In this video, we're going to cover the fundamentals of working with quadratics, starting with the expansion and factorization of quadratics. For those who don't know me, my name is Chris Iannazoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. We know from our studies in linear that the multiplication of bracketed terms can be distributed through those terms by multiplying each term in the bracket. But what happens when we have two bracketed terms? The concept is actually the same. To make things easier, let's replace the first term with the letter A. Now when we expand, we're going to get AC plus AD. All we got to do from here is replace A with what it actually is. And from there, you just expand the terms individually. So in this example, it means we have 2x multiplied by x minus 3 and 1 times x minus 3. All we do is just expand those out and collect the like terms. If you have more than two bracketed terms, then all you're going to do is solve them two at a time. In this example here, we're going to start by solving the first two bracketed terms. When you're doing this yourself, I recommend using square brackets around the terms that you're trying to solve, just so you can keep track of what you're doing a lot easier. Then, once you've expanded that first set, we're just going to expand the new set. Just be aware that this time you're going to have 3 terms in that first bracket instead of 2. So you're going to have to perform the multiplication 3 times. Once again, you just expand and collect all the like terms. A perfect square is a term that takes the form a plus b all squared. And such a term can be immediately expanded by memorizing the following equation. In this example, a is going to be 2x and b is going to be 1. All we do from here is plug and play and then simplify the result. You don't really need to use this method specifically, but it does save a bit of time. You can actually use the previous method if you rewrite a plus b squared as a plus b times a plus b. Those things are identical. The difference of two squares is quite similar in that it's just a plug and play. In this case, we're looking for a plus b and a minus b. Once you have that, that will immediately expand out to just be a squared minus b squared. Once again, you don't strictly need to know how to do this method. It does save you a bit of time if you do bother to learn it though. In this example here, we have a equals 2x and b equals 4. So the fully expanded version is going to be 2x all squared minus 4 squared, or simplifying down to just 4x squared minus 16. If you use the first method instead, you'll see it simplifies down to the same answer anyway. It just saves you a bit of time otherwise. This method is actually a bit more important when it comes to factorization, rather than expansion. But we'll look at that later in the video. Factorization can be thought of as the reverse of expansion. The most basic form of factorization is the removal of common factors. If a factor belongs to 2 or more terms, then that factor can be taken out the front as a common factor. In this case, both terms contain x, so x can be taken out the front as a multiplication of a plus b. You can always check your factorization by immediately expanding it back out. If you get back to exactly where you started, then you probably did the right thing. Here's a more complicated example. In this case, we have x as a common factor of both terms, so we can take that out the front as a multiplication and just reduce the power of each of the previous x's. We can actually keep doing that until there are no more x's shared by both terms, which leaves us with x squared out the front. From here, we can actually go a little bit further. We don't have to take out just variables, we can also take out coefficients as well. We can see that 4 is a factor of 8, so we can take that out the front as well, giving us 4x squared out the front of 1 plus 2x. The grouping method is a slightly more advanced version of what we just discussed. The only difference here is that the common factors are a bit more complicated. Consider the following expression, and notice that this x plus 1 term is a multiplication of both of those terms. X plus 1 can be considered a common factor, because it's common to both of those terms, and hence can be brought out the front as a common factor. You can see this easier if you rename the terms. If you see the x plus 1 in both of those terms and think that it might be factorizable, then consider renaming it to something like capital A. From there, it's a lot easier to see how that factorizes. All you've got to do afterwards is replace A with what it was, x plus 1. Now, we're going to look at factorization methods that are specific to quadratics. There's only 2 cases you need to be familiar with. One where the leading coefficient is equal to 1, and the other where the leading coefficient is anything other than 1. If you have the first scenario, then you're going to use an add together times together method, which just means you're looking for 2 numbers that multiply together to give the c value, and also add together to give the b value. Once you have those 2 numbers, You arrange them in a factorized form as below. Let's consider the following example. We can start by creating a list of numbers that multiply together to give the C value, which in this case is 6. Just make sure to consider both the positive and negative combinations. Now that we have this list, let's see which of those also add together to give the B value, which in this case is 5. 6 plus 1 makes 7, so that's not quite right. Same thing with -1 and -6, that's going to make -7. However, 3 plus 2 makes 5, so that's the winning pair. Now that we have our pair, we're just going to arrange those in the factorized formula. It's worth noting at the end that this won't work for every quadratic. Some of them just aren't factorizable, but those that are can be factorized using this method. In the case where your leading coefficient is anything other than 1, we have to use a cross-product approach. Here's how it works. First, we're going to come up with two terms that multiply together to give the ax squared term, which in this case is 2x squared. You only need to test integer coefficients of x, so this list in particular will only have one result. Next, we do the exact same thing, but with the c term, which in this case is 6. Now that we have our list of factors, we're going to arrange them in a cross-product format. To start with, you're just going to pick any two pairs of your factors and arrange them however you like. This will just give us a starting point. From there, we're just going to perform the cross product, which simply means multiplying along the diagonals and then adding the results, which in this case is going to give us 13x, but that's not quite what we were looking for. The goal is to arrange our factors in such a way where the cross product gives bx, which in our case is just 7x. We didn't get that result, we got 13x, so we need to do something different. The first thing we can do is just try to change the order of our factors. Let's try swapping the 6 and the 1. And when we do that, you can see that the cross product gets a different result. Still not quite right, but it is different. The next thing we can do is just use a different set of factors altogether. And after a bit of trial and error, you'll find that if you use the factors 2 and 3, you're going to get the result that we need. Now that we have our factors, we're just going to write those left to right as depicted. The last thing we're going to look at is how we can use difference of two squares to factorize. The entire aim here is to make sure that our equation looks like the right-hand side of the difference of two squares equation, which just means we need one squared term and then subtracting another squared term. X squared minus 9 is pretty close, actually. All we have to do is rewrite 9 as 3 squared, and we have what we wanted. We have x squared, we have 3 squared, and those terms are separated by a subtraction. So all we do is substitute into the left-hand side of that difference of two squares equation. Once again, you don't strictly need this specific method to factorize quadratics. You can just use case 1 that we looked at earlier, where you're just going to find two numbers that multiply together to give -9 that also add together to give 0, since that b term is absent. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.